second goal for section 2.3 is to be able to take derivatives using quotient rule. Well, when do we use quotient rule? Quotient rule is a little bit easier to recognize because you look at this and you go, okay, I definitely see a fraction. That's still a single term, so I'm going to do a single derivative, but now I'm going to have to do it with some sort of division thing. So I'm going to label the same way. I'm going to call the top function red, and I'm going to call the bottom function blue, and I'm going to zoom this in again to make it a little bit easier for some more space for me to write. So product rule and quotient rule. Product rule up there on the top, you had two things being multiplied, so you created two terms, and you took the derivative of each piece once. When you look at quotient rule, you're going to do a lot of the same things. It's going to work a little bit differently. And what a lot of people will say is, all right, we're going to do low d high less high d low, square the bottom, and away we go. And whoa, what did you just say? So here's what this looks like. First off, with quotient rule, you're dividing fractions, so your result's going to be a fraction. But now this one gets a little bit more specific, and here's what happens. Slow motion replay of what I said. Low. Okay, well, what is low in this function? Looks like the bottom or the blue function, low, g of x. D high, D standing for derivative. Derivative of the high function would be derivative of the red one, which would be f prime of x. Less would mean subtract. High, well, what's the high function? High function's red. D low would be the derivative of the low function, so low function's blue. Derivative would be g prime of x. So low d high less high d low. We got the numerator set. Square the bottom. The bottom would be a g of x function. And away we go. So let me put that back together again. Low d high less high d low, square the bottom, and away you go. So that's quotient rule. Look at this corny little song that somebody made up I don't know how many years ago. But it is kind of funny how people can keep track of that. So let's come down and let's try this a little bit. So g of x, pretty complex, a lot going on. I will tell you that using the advice from this problem number 1 we did a few minutes ago, if we don't change the original, it's going to cause us double the algebra when we're all done with this thing. So let's change the original, because as it is, I would need to, well, what I see there is I see a fraction that happens to have a product in its numerator. So when you would do the derivative, you'd do the exact same thing. You would do the quotient rule, and when it comes time to take the derivative of the numerator, you'd have to do product rule. We don't want to do that. So let's change this original. So changing the original, I'm going to multiply out the top. So how about 12x cubed minus 3x minus 16x cubed. Oops, sorry, this should be a 12x to the fourth. Let's fix that. Minus 16x cubed plus 4 over the top of 2x plus 3. So now we clearly have a single fraction, and that single fraction has a numerator with 4 individual terms and a denominator with 2 individual terms. So we're going to need to do quotient rule here to do the one derivative, and then when it comes time to do those derivative of the red and the blue respectively, we're going to have to work at it a little bit. So here we go. Move this over as far as I can. So derivative g prime of x low 2x plus 3 d high, derivative of the red function, 48x cubed minus 3 minus 48x squared, and then plus a 0, less high, so all the red function, 12x to the fourth minus 3x minus 16x cubed plus 4. D low, well, what D low? D low is the derivative of that blue function. Derivative of the blue function is just a 2. Square the bottom. And away we go. So there, the calculus is now over. This has now become a pretty rambunctious little algebra problem for us to work on. So now we got to clean it up. Mr. Perkins, I don't want to clean it up. I get that. But the problem is if you're eventually going to use functions like this to model situations, to represent things, and you're going to have to be able to come up with specific characteristics from this equation. So you got to be able to handle the algebra. If you can't, you don't want to, that's one thing. You need to be able to in order to be successful in a class like this. So I'm going to start out by, let's distribute this 2. So if we do that, I've got 96x to the 4th minus 6x minus 96x cubed, and then we'll distribute the 3. If we distribute the 3, I've got plus 144x cubed minus 9 minus 144x squared. And then over on this side, we're going to have to distribute the negative and the 2 while we're at it. So I'm going to kind of do that in one shot. So I'm definitely going to need more space. So if I take a negative and the 2 and distribute it effectively, then I'm going to have a negative 24x to the 4th, a plus 6x, a plus 32x cubed, and a minus an 8. That's my numerator. In your denominator, I'm going to say this now, and I want you to internalize it as fast as possible. Never, ever, ever multiply out a denominator. Why? Because if I said right now, where is this function undefined, or where's this derivative undefined, you'd set 2x plus 3 equal to 0, and you'd find out at negative 3/2. It doesn't exist. If you multiply it out, now you've got to reverse that process in order to answer that same question, and that's a really important question for us, as we've already found doing things like continuity and differentiability and things like that. So put all this together, how's this going to work? So 96x to the 4th minus 24x to the 4th is about 72x to the 4th. X cubes. Here's negative 96 of them. Here's 144 of them. And I think there's another 32 of them over this way. So 144 plus 32 is 176. 176 minus 96 is a plus 80, I think, x cubed. Forgive me if I'm wrong. Let's see, x squared. It looks like we only have negative 144 of them. X's, I see now a negative 6x and a positive 6x, so they're going to drop out. And last but not least, we have a negative 9 and a negative 8 for a minus 17 over the top of a 2x plus 3 quantity squared. And I really hope we never have to set that numerator equal to anything and be able to solve it. But we do know how. So there's our quotient rule, and away we go.